So here we have 2016, this is question 2 and this is Leaving Cert Ordinary Level and it's on complex numbers. So we're told that Z1 is 1 plus 3i and Z2 is 2 minus i, and they're saying I squared is equal to minus 1, so they're saying these are two complex numbers. So they're saying let Z3 be equal to Z1 plus Z2 plus 2Z2. So so I have to add these together. So Z3 is equal to, so first I actually might get 2Z2. So I have to multiply Z2 by 2. So 2 Z2 is going to be 2 multiplied by Z2. So I have to multiply the 2, this by this, and this by this here. So 2 by 2 is 4. 2 by minus I gives me minus 2i. So that's what I get from 2Z2. So I have to add Z1 plus 2Z2. So Z1, I have that there, so that's 1 plus 3i. And then I have to add with that 4 minus 2i. So I have to add, my real parts are the parts that don't have an I, so this is real, that's real, and my imaginary parts, I'll circle them, are the ones that have i's. So I can add the real together and the imaginary together, but they have to be separate, dealt with separately. So 1 and 4 gives me 5, so 3i take 2i, so that gives me plus I. So Z3 is equal to 5 plus I. So then the next part, we are asked to plot Z, so I'll just write in the corner each of our points. So Z1 is 1 plus 3i, Z2 is 2 minus I, and Z3, which we figured out, is 5 plus I. So Z1 is 1 plus 3i, so we go across 1 on our real axis, and then up 3 on our imaginary axis, and then we get, this is Z1, so my diagram isn't going to be 100% accurate because I don't have graph paper. So Z2 is 2 on our real axis, and then minus I, so minus 1 on our imaginary axis. So here we have Z2, and then Z3 is 5 plus I, so we go across 5 on our real axis, and then we go up 1 on our imaginary axis, and then here we get Z3. So the real axis is the horizontal axis, and the imaginary axis is the vertical axis. And then for the next part of our question, we are asked to investigate a few things. So I'm just going to write our points at the top of the page because we're going to need to use them. So 2 minus I and Z3 is 5 plus I. So we are asked to investigate if so when we have two lines at either side of something, that means the modulus, and the modulus, what it literally means is the distance from the origin. So say for example, if I have Z1 here, the modulus of Z1 is this distance here, the distance that brings it to the origin. The modulus of Z2 is the distance bringing it to the origin. The modulus of Z3 is the distance linking it to the origin. So that's what the modulus is. So the modulus of any complex number, so say if we have just a complex number here, and we'll say this is a plus bi. So say it went across a and it went up b. Well, what we want is this distance here. Let's call it, we'll call it or. So or, if we were to use Pythagoras, or squared would be equal to a squared plus b squared. So or just by itself is going to be equal to the square root of a squared plus b squared. So the modulus of a complex number, if you have a complex number a plus bi, the modulus is equal to the square root of a squared plus b squared. So that's going to be helpful to us. So the first thing we want is the modulus of Z2 minus Z3. So the first thing we're going to have to do is get Z2 and subtract Z3 and then get the modulus of that. So Z2 minus Z3, so Z2 is 2 minus I, and I'm going to minus all of z3, so I'm just going to use a bracket. So 2 minus I, so that'll be minus 5 and minus I. So 2 minus 5, so that gives me minus 3, and minus I, so that gives minus 2i. So this here is z2 minus z3. But I was asked to get the modulus of that, and I'm just going to bring my page down. So z2 minus z3 is what I just got here, so it's minus 3 minus 2i. So if I want to get the modulus, so when I put 2 lines on either side, that means the modulus. So it's going to be the square root of minus 3 squared plus minus 2 squared, because our a is minus 3 and our b is minus 2. And we don't put in i's when we're dealing with the modulus. So minus 3 squared gives us 9, and then 2 squared gives us 4. So then we get the square root of 13. So the modulus of z2 minus z3 is equal to the square root of 13. But we were asked to investigate if that's equal to the modulus of z1 plus z2. So firstly, I'm going to have to add z1 and z2 and then get the modulus. So I do what's in the bracket first and then get the modulus of that. So z1 is 1 plus 3i, z2 is 2 minus i. So z1 plus z2 will be 1 plus 3i plus 2 minus i. So that'll be 1 plus 3i plus 2 minus I. So my real parts can be added together. My 1 and my 2, which will give me 3. And then my 3i and my minus I. So that'll be plus 2i. So that's z1 plus z2. But in order to get the modulus of z1 plus z2, remember that if I have a complex number a plus bi, the modulus of a plus bi is equal to a squared, square root of a squared plus b squared. So the modulus of z1 plus z2 is equal to the square root of 3 squared plus 2 squared. So that's going to be 3 squared is equal to 9, and then 2 squared is equal to 4, and then the 9 plus 4 is 13. So for the last one that we just did, we got that the modulus of z2 minus z3 is equal to the square root of 13, and now we're just after getting that the modulus of z1 plus z2 is equal to the square root of 13. z1 plus is equal to the square root of 13, and as they're both equal, so the square root of 13 is equal to the square root of 13, so therefore z2 minus z3 is equal to z1 plus z2. So we have verified that. So then the next part of that question, we are asked to, so I'll just get another page. So we're told that W is equal to Z1 over Z2, remembering that Z1 is 1 plus 3i and Z2 is 2 minus I, and they're asked to, so W is Z1, which is this, 1 plus 3i over Z2, which is 2 minus I. So now I have one complex number divided by another complex number, and I'm asked to express it. They won't accept it if I just leave it like that. I have to have it in this format, a plus bi. So when I have one complex number divided by another complex number, I'm going to have to do a few different steps. The first thing I need to know is what a conjugate is. So say if I have the complex number 2 minus I, the complex number is, the conjugate of this is when we change the sign of the imaginary part. So it'll become 2 plus I. And the thing that makes the conjugate useful for us is if I multiply a complex number by its conjugate, I get rid of the imaginary parts. I don't have any i's left, and I don't want to have any imaginary parts on the bottom of my fraction because that's not the way they want it in the question. So if I am going to multiply the bottom by its conjugate, but in order if I don't want to change the equation, I have to multiply the top and the bottom by the same thing. So I'm really only basically multiplying by 1. So my steps are, we multiply top and bottom, of the fraction by the conjugate of the bottom. So my fraction is that I have is 1 plus 3i, and then that's over 2 minus i. So I already got the conjugate of that is 2 plus i. So I have to multiply top and bottom by 2 plus i. So that's going to be 1 plus 3i by 2 plus i, and then 2 minus i by 2 plus i. And if I multiply something by the exact same thing on the top over that thing on the bottom, I'm really only multiplying by 1, so it does not change it. So now I have to kind of split my bracket and multiply 1 by my second bracket, and then my 3i by my second bracket. So 1 by 2 plus i, and then 3i by 2 plus i. Then here I have to multiply 2 by my second bracket, and then I have to multiply my minus I by my second bracket. So it'll be 2 by 2 plus I, and then minus I by 2 plus I. So here we have 1 by 2, which gives us 2, 1 by I, which gives us I, 3i by 2 gives us 6i, 3i by I gives us 3i squared. 2 by 2 gives us 4, 2 by I gives us 2i, I minus I by 2 gives us minus 2i, and then minus I by I gives us minus I squared. So we're going to try simplify this a little. So I have, bring it down here, so I have 2, so I have I plus 6i, so that will be 7i plus 3i squared, and then 2i minus 2i, so that'll just be 0. So 4 minus I squared. But in the question, and I would recommend knowing this also as well, it says that I squared is equal to minus 1. So wherever there's an I squared, I'm going to sub in minus 1. So say here it'll be 2 plus 7i plus 3. But instead of putting in I squared, I'm going to put in minus 1. And similarly on the bottom, so that'll be minus 1. So now I'll have 2 plus 7i minus 3, and then 4 minus 1, so that'll be 4 plus 1. So 2 minus 3, I can put my real parts together, so that will be minus 1 plus 7i, and then over 5. So now I have to divide my real part by 5 and my imaginary part, but I do not have any complex parts on the bottom now, so that's what I wanted to achieve. So it's minus 1 over 5, and then plus 7 over 5i. And I can't simplify that any further, and they wanted a and b to be real numbers, and they are real numbers, so that is my answer for that part.